Okay, here's an example of a problem where we want to convert a circle's equation from general form into standard form, but we have some coefficients on the x squared and the y squared term, which might make the process of completing the square a little trickier than it normally would be. So let's work through this together so we can see how it's done. First step in completing the square is to take your terms that have x's, get those grouped together, and then the terms that have y's, and get those grouped together, and your constant to the other side of the equation, which in this case would make that a negative 24. Now at this point, we would take the number that's multiplying x and divide it by 2 and then square it and add that value to both sides of the equation. That's the process of completing the square. But because we have a coefficient, we can't do that just yet. We have to first divide out the coefficient. I can either factor it out of these parentheses, or I can just, and I think this is what I'm going to do, I'm going to divide both sides by 4. And you can do any operation you want as long as you do it to the entire side. So I have to divide every single term here by 4. So that's going to make my problem look like 4x squared divided by 4 would just be x squared. And then 25x over 4, best I'm going to be able to do there is write 25/4 of x. Then I'm going to leave some space because I need to complete the square yet. And then my y terms, the 4's will cancel, and 4y squared over 4 gives me y squared plus 13/4 of y. And on the other side of the equation, 24 over 4, those reduce and we'll make that negative 6. Okay, at this point, completing the square, what we would do is take whatever number is multiplying x, and I'm going to go to the side here and do this. So my number multiplying x is negative 25/4. What I need to do is divide that value by 2 and then square it. I'll handle the squaring in just a second, but for right now, let's divide by 2. Now, of course, when we're dividing fractions, we don't actually divide. What we do is we invert and multiply. So I'm going to make the denominator a fraction. So 2 over 1 is the same thing as 2, so that I can invert that denominator, make it 1/2, and so I'm multiplying by a half instead. And then we can now see that this would become negative 25/8. Okay, now again, I did skip the step of squaring, so I need to go back and make sure everything gets squared. And negative 25 squared, that's going to be 625, and 8 squared is 64. So the number that is going to go here for the process of completing the square is 625 over 64. And you can't put that on one side without doing the same to the other. So I'll go ahead and put it on the other side as well. Okay, now 13/4 is going to change in the same way. So 13/4 divided by 2 will be 13/8. And then when I square 13/8, it will be 169 over 64. Oh, I put a 4 there. I apologize. Good thing I saw that. Okay, so now I am at a point where I can proceed. Okay, so first off, when I am completing the square, the next step in this process is to take this perfect square trinomial and factor it. Now, if you are actually doing a process of factoring, like looking for two numbers that multiply to the constant and then add up to the middle number, you're wasting your time because since this is a perfect square trinomial, it's always going to factor into the form x plus half of this number. So half of negative 25 fourths is 25 eighths quantity squared. Okay? You don't have to do any work really when you are factoring a perfect square trinomial. So when you're doing completing the square, no matter how bad with fractions or anything this looks, this factoring is actually pretty straightforward. So let's try it again with the y's. If I take the y's and factor it, it should become y plus 13 eighths quantity squared. Okay, now the only thing left to handle here is this fraction over here. And to handle the fraction, let's see, the first thing I'm going to need to do is get common denominators among each of these fractions. So negative 6 needs to be rewritten. So negative 6 as a fraction with a denominator of 64. Bring up my calculator. And let's see, so negative 6 times 64, that is negative 384. And then I just need to add it to these fractions that already have denominators of 64. So let's see, negative 384 plus 625 plus 169, that gives me 410. So 410 over 64. And that's really a fine answer, but you should always give simplified fractions whenever you can. And I definitely see that the numerator and denominator could be divided by 2. I don't know if that's the largest number that would go into them, but let's see, that would be 205 over 32. 32 is a power of 2, so its factors are only 2, so 205 has to have a factor of 5 in it, and I don't think it's going to have any. I'm sorry, I'm just thinking out loud here. Yeah, so it's not going to reduce any further. So that is my reduced fraction. So this equals 205 over 32. So at this point, we have our final answer in standard form, which is what's requested. So this is what we can provide as an answer. Now, if we had been asked to give the center and radius, well, then we would continue on, and the center would be at 25 eighths, negative 13 eighths, and then the radius would be the square root of this fraction here. So that would be our answer then, but in this case, since we're only asked to change this into standard form, we're all set with this equation.